Good morning, all of you. Myself, Ravindra Kalebere. I pursuing my PhD under the guidance of Dr. Sensetti UB, Jawahar Art Science and Commerce College, Andur, District Osmanabad. My research title is A Studies of Water Quality, Seasonal Changes, Synthesis of Corrosion Inhibitor to Control the Corrosion in Different Metal of Industrial Process on a Bhima River water near Uzni Dam Reservoir. Basically, my topic is related with physicochemical analysis of water, corrosion caused by the water, and anti-corrosive treatment for the different metal, and synthesis of triazole-based corrosion inhibitor. My research objectives are to assess a physicochemical and biological characteristic of surface water of Bhima River and Uzni Dam for 4 different seasons in the year. Second is to determine the water quality index. There are the different index. We are using Langmuir saturation index of a surface water covering 100 km of river stretch of Uzni Dam, where lot of MIDCs are situated, or they are using the water for different process purposes. Third one is to analyze the problem of corrosion in industries, especially in power plant industries, where cooling purposes water is used with the anti-corrosive and anti-scalive treatment, and to observe the corrosion rate by the corrosion coupons. Corrosion coupons is the metal strip for same metallurgy implanted under the chemical treatment to calculate the life of that equipment. Fourth one is to study brief seasonal changes in the water quality throughout the year along the Bhima River and backside of the water, and take a review of present chemical treatment implanted by or used by different industries during a regular process work. And my fifth, to research out the best corrosion inhibitor, either organic or inorganic base, which will give a standard result or standard chemical treatment as per the seasonal changes of the water with optimum doses, and all these will be predicted in tabular form and graphical form in my thesis. Presently, I go 80 research paper and 5 research articles as a reference and 10 books. These 5 articles totally emphasize on the present situation of the water quality of Uzni Dam. Why? These books are giving a different type of schemes to synthesize 1, 2, 3 triazole as a corrosion inhibitor. Overall conclusion from literature survey is that the studies of water quality and seasonal changes in Bhima River, particularly near Big One in Maharashtra, is fluctuate, and it also examines synthesis of corrosion inhibitor controlling a corrosion in the different metal those are used in various equipment. These inhibitors are critical to protecting the industrial equipment from the corrosive efforts, which is influenced by the seasonal variation of the water quality. I am talking about the present corrosion inhibitors. Literature survey suggests that both inorganic and organic inhibitors are effective with a growing interest in environmental friendly, and which gives more benefit protecting the industrial infrastructure, minimizing the equipment impact. For this purpose, we selected build graphic papers big one as a case study where we can observe the present or used chemical treatment by these industries and the corrosion rate calculated by the industry. The build graphic paper used orthophosphate. Build graphic paper used the orthophosphate as the anti-corrosive inhibitor for the mild steel metallurgy. When we observe that in September 23, The dose of the orthophosphate was 10 ppm for the total system, and the corrosion was 1.2 mpy. Mpy means mile per year, that is the destruction of metal unit. When we go through April, October the dose was same, November it is raised by 5 ppm, and February onwards it goes a drastic increases in the dose. In April, it is a 30 ppm. When we compare that 30 ppm dose with September, that means 3 times increases. Similarly, when we look for the corrosion rate, it was 1.2, but presently it is a 4.4. That means that orthophosphate have a limited scope to control the corrosion in my state if the water quality get deteriorated. Similarly, we observe the result of bibliographic papers. They are giving a triazole and benzotriazole as an anti-corrosive inhibitor for the brass metallurgy. With 10 ppm dose, we found in September the corrosion rate was 1.2 mpy. When we go for the April, the dose for the both chemical is 35 ppm. That means huge consumption increases in both the chemicals, but still corrosion rate is going on increasing. That means the present chemical treatment unable to control the corrosion or destruction of metal under effective control. That means chemical consumption go on increasing, and other hand the rate of corrosion also go on increasing. That is happen because of the water quality deterioration. Some testing coupons, we put the photographs here. This is the brass metallurgy before exposure to water, and this is the MS metallurgy before exposure to water. And after 15 days, the situation or the physical appearance of these two coupons will be like that. These corrosion rates are calculated by ASTM standard methods. From September onwards, we start the water analysis of Uzni Dam. We call raw water because that raw water used in process as a coolant medium in cooling tower. We decided the frequency for date 1 to 10. Any one date we can analyze these water samples at the same time, raw water and cooling tower. For 11 to 20 and for 21 to 30, we observe that for all September month, the water TDS for raw water almost same, because when we at the end of month it is a 400 ppm, and at the starting of month it is a 380 ppm. At the same time, we calculate the Langelier saturation index. It was 0.29 ppm, and at the end of month it is a 0.7 ppm. It is a best under control. Similarly, we make water analysis for the month of October, month of November, month of December, month of January, month of February, month of March, month of April, and we found that or all the results we concluded in one tabular form, and that results clearly interpret that at the September or in the month of September, the TDS was 240 for the Uzni Dam water, and the LSI was 0.49, and at the in April that TDS is 460. That means almost it get double, and similarly LSI will get increased up to the 2, and it is a close to the higher limit because the ASTM standard method set the Langelier saturation limit is 0 to 3. Similarly, we concluded the cooling tower analysis here. Similarly, for September to April, we found that TDS level in go on increasing. That TDS level can be controlled by deliberate blowdown from the system, and deliberate blowdown or excess blowdown is also responsible for the losses of excess chemical from the system, and that chemical ultimately increase the consumption. So when we look for the Langelier saturation index, it is near about 3. That means it is close to the border. the water is fully in scaling tendency. Same result we are interpreting in the graphical form. We clearly seen that from September onwards, the water TDS is go on increasing. We selected one parameter because the TDS, that is the total dissolved solid, involve all parameter indirectly. When we calculate the Langmuir saturation index, we found that it also go on increasing huge with water TDS. These are the some photographs of the coupons after 30-day exposure. At the same time, we tried to compare the Langmuir saturation index versus corrosion rate. This graph represent the corrosion rate versus the Langmuir saturation in mild steel. That red color bar indicate the mild steel corrosion and blue color bar are indicate the Langmuir saturation index. That graph clearly indicate that the Langmuir saturation index is close to 2.5. That Langmuir saturation index taken for the only cooling tower system, not for the raw water, because we want to study the anti-corrosive treatment in a cooling tower. At the same time, corrosion also go on increasing in huge quantity. Similarly, we compare LSI versus brass corrosion, and we found as the LSI grows on increasing, corrosion in brass also go on increasing. So that we try to synthesize the 1,2,4 triazole after literature survey. We found that that compound having a best anti-corrosive property for different type of metal like copper, aluminium, mild steel. So we set a scheme for the synthesis of 1,2,4 triazole from the alkyl formhydrazine and formazide. But this scheme having a two limitation. One is the low yields. This synthesis yield on the alkyl, the aryl hydrogen typically result in a low yields, and this efficiency can limit practical application and scalability of this method. Second problem is that difficult in the separation of pure or desired 1,2,4 triazole. After satisfactory yield, we will go for the physical characterization of that product like NMR, boiling point. We right now we test the synthesis with the TLC method. We are not mentioning here actually. Despite of that, the ability of synthesize di and tri-substitute 1,2,4 triazole make this reaction valuable because it is a significant compound, especially in a material science. It is important in pharmaceutical and agriculture, no doubt about that. But we want to use as an anti-corrosive because 1,2,4 triazole with optimum dose gave a best result for different metals. Second scheme is synthesis of 1,2,4 triazole from the thiocyanocarbazole. This scheme is under work. So right now we concluded that since September 23, the water analysis clearly indicate that the TDS level go on increasing, at the same time Langmuir saturation go on increasing, and it forced to increase the scale as well as corrosion in system, and for that to control the corrosion and scaling, the dose of the anti-corrosive treatment will be increased, and it put an adverse effect on a financial expenditure for the different type of company. So our focus is that to synthesize a thiazole based corrosion inhibitor which gives effective control for the different type of metal with optimum dose. Thank you very much.